Good day. Thank you for watching this video and studying math with me. Today we're going to study polynomials, reviewing exponents and fundamental operations of polynomials. These are the rules of exponents. For all positive integers m and n, and all real numbers a and b, we have the following rules. When we multiply factors that have the same base, you can add exponents. We have a second power rule. If a to the m is raised to the nth power, you will multiply these exponents. If you raise a product to the nth power, the exponent is distributed to each factor, and similarly for a quotient, as long as the denominator isn't 0. As long as a is not 0, a to the 0 is 1. And 0 to the 0 is undefined. Let's look at some examples. M to the 6th times m to the 8th. We're going to have the same base, so we can add the exponents. We get m to the 14th. Here, we're going to have r cubed, r to the 4th, times that's r to the 1. You add those numbers, you get r to the 8th. If you multiply all the coefficients together, you will get a positive 90. Here the base 7 cubed is raised to the 5th power, and so you're going to multiply exponents and you'll get 15. Down here you apply the factor of 4 to both factors, and 2 to the 20th times y to the 12th. Here I apply the exponent of 5 to both numerator and denominator, and simplify, getting 4 to the 15th, z to the 10th. Here, when I square the negative, I get a positive. That's going to be 9, a to the 6th, b squared, remember there's a 1 there, and c to the 8th power. As long as b is not equal to 0, here we have an exponent of 0 and a base that's not 0, that's going to be 1. Here, the base associated with the exponent of 0 is minus 8, then it's taken times a minus 1, so that's going to be minus 1. Here, there's going to be 1 because the base is minus 8. Here, the base is 8, so it's going to be minus 1, and that's going to be 1 as we discussed previously, because the base is 8. We are going to talk about simplifying polynomials, and that's going to involve the concept of like terms. Like terms are separated by plus and minus signs. Terms are separated by plus and minus signs. Like terms have the same variables and the same exponent. A coefficient is the number portion of a term, including the sign, and the degree of a term is the sum of the exponents associated with the variables. The degree of a polynomial is going to be the highest degree found in the polynomial. So here we have two plus or minus signs, and so I have three terms called a trinomial. The degree, the highest degree I see is 4, so the degree of the polynomial is 4. Here, the sum of the degrees of the exponents and the variables is 7, and so the degree is, as it's only has one term, a monomial, like a monorail, and so the degree is 7. Here, both terms are degree 3, so the degree is 3, and I have two terms, so it is a binomial, like a bicycle. Now I'm going to add and subtract polynomials by combining like terms. So here I will have the 17x cubed combined with the minus 9x cubed. The net is that. Here the x squareds will cancel one with another because they're negatives of each other. And here I will have x minus 5x is going to be a net of minus 4x. Here I'm going to have minus 7m to the 4th. This is going to be a positive 6, but that's a negative 11. So it's a net of minus 5. And here this is 21 minus 35 is going to be negative 14. here, the like terms are the ones that have the same variables and the same exponents. So these are the like terms that I combine. So when I combine these, I will get 35r cubed s to the 6th. When I combine these, I will get negative 10 r to the 6th s cubed. Here I will distribute across, and so I will get 6z squared minus 30z plus 18. Here I will get minus 12z squared plus 8z minus 36. When I combine those, I get minus 6z squared. I'll get minus 22z, and I will get minus 18. Here I'm going to stack these and multiply them. I could just distribute. So minus 5 times that is this. Minus 5 times minus 2t is a positive 10t, and minus 5, and that's going to be 3t squared, so it's a net of minus 15t squared. Moving to this one, and I put like terms under like terms to combine them. That is going to be a positive 28t. That's going to be a negative 8t squared, and that's going to be a positive 12t cubed. So I will add down, and I will get this as the answer. Here I'm going to be expanding just by distributive property. So this is going to be 7y times 4y is 28y squared. 7y times minus 5 is minus 35y. I'll move to the next term. This is going to be 3 times 4 is 12y minus 15. I will combine like terms in the middle, and I will get this as an answer. That's how we'll multiply binomials. Now here I have, this is of the form a minus b times a plus b. So the middle term here will be a 66p, but this will be a negative 66p. They will cancel, so the middle terms will cancel. So I really will just get this, and that's going to be 36p squared minus 121. Now here I have a similar situation happening with those. So this is going to be x cubed, and then this is going to be, so now I will distribute that across, and this is going to be 4x to the 5th minus 25x cubed. And we can codify what happens in these cases. If I have the form x plus y times x minus y, it will end up being a binomial, x squared minus y squared. If I have a plus or minus sign, I will have these forms. X plus y whole squared is x squared plus 2xy plus y squared. X minus y whole squared is going to be x squared minus 2xy plus y squared. That allows us to quickly do some products. Here this is the form x minus y times x plus y. Similarly here. And similarly here. This is going to be using the other special products that we studied. So this is going to be 64 z squared plus, that is going to be 48 z plus 9. This is going to be 25 z squared minus 120 q cubed z, and this is going to be plus q to the 6th. We can do that in stages. Here we have something of the form a plus b, a minus b. So this will be then it will expand this and so that is the answer to that problem. We can have something being a little bit more involved like this. This is the same thing as a minus b squared times a minus b squared. So when I do the multiplications, I'm going to get a to the fourth minus 2a cubed b plus a squared b squared. I'm going to expand this. This is going to be minus 2a cubed b. This is going to be plus 4a squared b squared. And this times this is going to be minus 2a b cubed. Lastly, I will expand this. It's a squared b squared. This is going to be minus 2a b cubed. This is going to be plus b to the fourth power. I will combine like terms. I'll have a to the fourth. And there's only one term with a to the fourth. Now we'll look for a cubed b. And a cubed b, I will have these, is going to be minus 4 a cubed b. And now I will look at a squared b squared. I will have these terms. That's going to be 5 and 1 is 6. And then I will have minus 4. This is going to be a b cubed plus b to the fourth. And so that would be the answer to that problem. When we're dividing this by this expression. We set it up like this. The 3n plus 2 goes on the outside. So we ask ourselves, and we make sure this is arranged in decreasing powers of n with no blanks. So 3n goes into 12n squared, 4n squared. I will get 12n cubed plus 8n squared. Now I'm going to subtract. When we subtract, we change the signs of the bottom numbers and add. It's going to be 3n squared plus 5n. 3n will go into this one time. That will be 3n squared plus 2n. We subtract by changing the signs of the bottom numbers. Get 3n minus 8. So this will go in there one time. That is 3n plus 2. I'm going to subtract and change the signs of the bottom numbers and add, get minus 10. So the answer to this problem is 4n squared plus n plus 1, and this is my remainder. And the remainder is written in this form over the divisor. So that is the way you can write the answer to that problem. Now sometimes there's a missing term. Here, for example, you see there is no x over here, and here you see there is no x cubed. So it's convenient to replace those by 0 just so we don't get confused. So we're going to divide x squared goes into this, and we would then will multiply. So we get squared, we get 0x cubed, and we get 8x to the fourth. We subtract, that means we change the signs of the bottom numbers and add. And this will go in here minus 4 times. And that will be 0x, and that will be minus 8. We now will subtract, so we'll change the signs in the bottom numbers and add, and we will get 7x minus 10. Now the degree of this is less than the degree of that, so the answer to this problem is the remainder divided by the divisor. And so it goes with polynomials. Until next time, take care, and remember, time is precious. Each day must count. Do the math. It will make you strong.